Hello everyone. In the continuation of first unit, that is solubility of drugs, today we have to see 2 points. What are the factors influencing solubility of drugs and what are the diffusion principles in the biological system? In last class we have seen what is solubility process, what is solute solvent interaction, in that mechanism, type of solvent, in types of solvent, polar, non-polar and semi-polar solvent, then solubility parameters, in that Hildebrand parameter and Hansen parameter, then application of solubility parameters, then solvation. In solvation again we have seen that factors affecting solvations like uh, agitation, heat, and one more is there. Total three factors we have seen there. Surface area, then association. In association, types of association, that is contact, solvent separated, then fully separated, then factors affecting association. In factors affecting association we seen that two factors, one is magnitude of charge on the ions and distance between the ions. Now coming to the next point, factors influencing solubility of drugs. There are several factors influence the solubility of drugs, which includes solute related, solvent related, environmental related factors, and formulation related factors. Last one. In solute related, again, structural features of drug, nature of solute, which includes size, shape, and surface area, how they will influence solubility of drug. Next, physiochemical properties of drug, physical form of drugs. In solvent related, nature of solvent. In nature of solvent, again, polarity, pH, volume of solvent, how they influence the solubility. In environmental related factors, temperature and pressure, whereas in formulations, last one, ingredient. Now coming to first factor, that is solute related factor. In that, first point is structural feature of drugs. Now chemical structures and functional groups decides the solubility of drug. Whatever chemical structures and different functional groups present on the drug molecule will decides the solubility of drugs. Now here some list of substituents are given and classification based on their hydrophilic or hydrophobic nature. Suppose any drug molecules contains substituents such as methyl group, methylene group, or chlorine, bromine, or fluoride ion, or dimethylamine, or thimethyl group, or ethoxy group, or methoxy group. These substituents influence hydrophobic nature on that particular drug, whereas groups like or substituent like CHO, COOH, CO minus, amine, ammonium ion, and hydroxyl group will influence the hydrophilic nature on that particular molecule. So effect of substituents also will be there on that. Effect of substituents also will be there on the solubility of drugs. Okay. Now, if suppose if number of functional group increases, solubility will also increases. For an example, in amino acids, if we increase the functional groups, it will increases the solubility. In second point, if number of hydroxyl groups increases, solubility also increases. For an example, in glycerine, glucose, sucrose, we have seen number of hydroxyl groups are more. So therein a solubility in aqueous solvents will get increased. But beyond certain particular point, it will get decreases, as in cellulose. Now cellulose is a polysaccharide which contains many number of hydroxyl group. Apart from that many number of hydroxyl group, cellulose is insoluble in water. So this is the exception where number of hydroxyl group increases, which will increase the solubility, but cellulose is exception. Next is functional group, which follows the Bronsted-Lowry theory, and Lewis theory promotes the aqueous solubility. Means these acid-base theories in solvent interaction, means those solute-solute interaction which follows this theory also promotes the aqueous solubility. Some compounds show more solubility when they are in salt forms, like alkaloid salts. Now alkaloid is a plant constituent. It is a nitrogenous base. Actually it is soluble in organic solvent, but in if it is in salt form, its aqueous solubility get increase. So some compounds show more solubility when they are in salt forms. Now branching of carbon chain reduces the non-polar effect and lead to increase the solubility. Now if you know that uh, straight chain carbon straight carbon chain will have non-polar activity, but branching of carbon chain will reduce that non-polar activity, and it leads to the increased solubility. Next, position of substituents on the molecule can influence the solubility. For example, aqueous solubility of ortho, meta, para, dihydroxybenzene are 4, 6 and 0.6 mole per dm, means mole per liter. Now position of substituent, here it is a ortho dihydroxybenzene, whereas hydroxyl group on the ortho position, here at meta, here at para, means two hydroxyl groups are present on the benzene ring, but their positioning, means position of substituent will influence the aqueous solubility. Now this might be due to the intramolecular or intermolecular hydrogen bonding. In para, the hydrogen bond, intramolecular hydrogen bonding will not be possible. That's why its solubility may be decrease. Okay, so this is an example for the position of substituent, how it will influence the solubility. In a molecule, ratio of polar to non-polar group also influence the aqueous solubility. Now ratio of polar to non-polar groups means, suppose in a molecule if more polar atom or more polar groups are present, then it will be having a more aqueous solubility, whereas if non-polar, it it might be having a more solubility in non-polar solvent. Now influence, second point is influence of particle size, shape and surface area. Suppose particle size is decreases, it will increases the surface area. You know, if surface area is increase, which leads to contact of solvent with more contact of solvent with solute molecule and increases the solubility. But beyond particular value, solubility decreases due to presence of electric charge on the smaller particle, which may cause agglomeration of particle, and that leads to decrease in the solubility. Next is symmetrical molecule may be less soluble than the unsymmetric molecule or asymmetric ones, because asymmetric molecules have more contact with the solvent molecules than the symmetric molecules. That's why asymmetric molecules are more soluble than the symmetric. Symmetric having a less solubility than asymmetric. Next, if crystals are compact, they possess high lattice energy and therefore solubility will be lowered. In crystals, you know that they having high lattice energy, so it is difficult to break the crystals. Therefore, their solubility will be lowered. Next is physicochemical properties of drug. Higher the melting point and higher boiling point indicative of low solubility of organic compound. Now melting point and boiling point are indicators of molecular cohesion. Now molecular cohesion means there will be an association between like molecules, means like and similar types of molecules with the cohesive forces attracted towards with the cohesive forces, and melting point and boiling points are indicators of molecular cohesion. So if higher the melting point and higher the boiling point, means it indicates low solubility, means there will be more energy required to break those molecular cohesion and convert that molecule into highly soluble organic compound. Here some examples are given. You can see N-pentanol and here 2-methyl 2-butanol. 2-methyl 2-butanol having a boiling point 102, whereas N-pentanol having 137. N-pentanol having the solubility 0.26, whereas 2-methyl 2-butanol having solubility 1.40. It indicates the lower the boiling point, higher the solubility, higher the boiling point, lower the solubility. Similar case, sulfadiazine melting point 253, whereas solubility 1 gram in 13 liter, whereas sulfathiazole 174 degrees Celsius, 1 gram in 1.7. So lower the melting point, higher the solubility, higher the melting point, lower the solubility. Okay, next point is ionized species have a greater aqueous solubility than unionized species. As we seen that ionized and polar solutes having more aqueous solubility than that of unionized species. Fourth point is physical form of drugs. This point again we have to see in next topic, that is state of matter in that polymorphism in detail, but some points we have to cover here. Amorphous form of drug have greater aqueous solubility than the crystalline form of drug. Whatever amorphous drugs are there having greater aqueous solubility than the crystalline. Among crystals, metastables form a greater stability than solubility than stable form. Now, what is metastable, stable? All this comes under polymorphism. In state of matter topic, we have to see the uh, polymorphism point, where it covers all these points, different forms of different polymorphs. There are again different types like metastable, stable. Next point is organic solvents. Organic solvents have greater solubility than the anhydrous form, and anhydrous have a greater solubility than hydrate form. In next one, salt form of drug have greater solubility than the non-salt form. This is about the physical form of drugs. Now, up to these 4 points, all this comes under structural uh, related parameters, or sorry, solute related parameters which influences the solubility of drugs. Next is nature of solvent. In nature of solvent, first one is polarity. The solubility The solubility of a drug is due to the polarity of solvent. It depends on the like dissolves like principle. Polar solvent dissolves polar and ionic solute, whereas non-polar solvent dissolves non-polar solutes. Simple. Second point is influence of co-solvents. Now, frequently solute is more soluble in mixture of solvents rather than in a single solvent. सिंगल सॉल्वेंट की बजाय अगर हमने मिक्सचर ऑफ सॉल्वेंट लिया तो solute will get more soluble than usage of single solvent. The solvent which used to increase the solubility of drug in water are called as cold solvent. Suppose any drug is poorly soluble in water. If we use another solvent to increase that solubility, that solvents are called as co-solvent. This phenomena is known as co-solvency, and such co-solvents are ethanol, propylene glycol, glycerin, PEG 300, PEG 400. And for example, in multivitamin preparation, propylene glycol used as a co-solvent along with the water. So influence of co-solvent also influences the solubility of drug. Next, influence of pH of the medium. Now, most of the drugs are either weak acid or weak bases, and they undergo ionization in the solution. Drugs are more soluble in water when they are in ionized form. Unionized drugs are poorly water soluble drugs. The extent of ionization of drug in solution depends upon the dissociation constant and pH of the medium. This we have studied earlier in the inorganic topic, inorganic chemistry also. Drugs, most of the drugs are weak acid and weak bases, and ionized drugs are more soluble than unionized drugs, and the extent of ionization depends upon the dissociation constant and pH of the medium. Now the relation between pH, P means preparation, pH of the preparation, solubility, and pK expressed as by using Henderson-Hasselbalch equation. For acidic drug, pH equal to pK plus log of S minus S0 divided by S0, whereas S is the total solubility of drug, that is unionized plus ionized, whereas S0 is the solubility of unionized form of drug. Now here some modification of Hasselbalch, Henderson-Hasselbalch equation is there. Earlier we have seen that concentration of ionized plus unionized. Here they have taken solubility of ionized and unionized. Similarly for the basic drugs, formula is there, and if the pH of the solution and pK, that is dissociation constant of that solution, is known, then solubility of drug can be calculated by using above equation. If you know the pH and dissociation constant for particular acid or basic drug, solubility calculated by using this formula. Now environmental related factor, and that first one is influence of temperature. Now solubility is directly proportional to the temperature. This means that if temperature increases, solubility also increases, but in some cases it is reverse. Means as you increases the temperature, solubility will get decreased. If system involves positive heat of solution, endothermic reaction, rise in temperature leads to increase in solubility. Means if system absorbs the heat, means endothermic reaction, rise in temperature leads to increase the solubility. If system involves negative heat of solution, means solute involves liberation of heat. Whatever solute presents are there present in a solution, they liberates the heat, means exothermic reaction, a rise in temperature leads to the decrease in solubility. Now solubility curves are developed by plotting solubility versus temperature, which helps to determine the effect of temperature on the solubility. Solubility curves are developed by plotting solubility versus temperature, which helps to determine the effect of temperature on the solubility. These solubility curves again we have to see in the future lectures. Now, influence of pressure. How pressure will be influenced? The solubility of gases is increased by the increase in pressure. Now, solubility of gases in liquid. In that topic, we have to see how pressure influence the solubility of gas in liquids. In gases, solubility of gases is increased by increasing the pressure. There is a direct relationship between them. Gaseous carbon dioxide dissolves in liquids for effervescent preparation under pressure. Some formulations like aerosols, inhalants, and duo, they contains the gases, pressurized gases in the liquid system. Okay, like gaseous carbon dioxide dissolves in the liquids for effervescent preparation. Now, Henry's law indicates when temperature is constant, solubility of gas corresponds its partial pressure. Means whenever temperature is constant, solubility depends on the partial pressure of the gas. This Henry's law again we have to see in the effect of solubility on effect of solubility or solubility of gas in liquids. Next, formulation related factors. In that first one is influence of common ion effect. The solubility of sparingly soluble electrolytes is decreased by the addition of second electrolyte that possesses similar ion effect as that of first one. Means suppose one electrolyte is there in a solution which is sparingly soluble, but its solubility will be decreased by the addition of second electrolyte, because second electrolyte possesses similar ion effect as that of first one. This is known as common ion effect. Means common ion effect will decreases the solubility of one electrolyte. Influence of surfactants having hydrophilic and lipophilic group, means they having both water loving and water hating groups, we can say this surfactant what they can do, which helps in the solubilization of poorly soluble drugs by micellar solubilization. Now micellar solubilization, this point will comes under surface tension topic. How surfactants will helps the poorly soluble drugs by micellar solubilization. Micellar solubilization is nothing but the formation of micellae which having hydrophilic heads inside and hydrophobic tails outside, which helps the poorly soluble drugs to dissolve in a solution by formation of micellae. Now that is after this what we have seen, the different factors influence the solubility of drugs. Next is the diffusion principles in the biological system. Now diffusion, it is defined as a mass transfer of individual molecules of substance caused by random molecular motion and associated with driving force such as the concentration gradient. In other term, diffusion also known as it is a net movement of material from area of high concentration to an area of low concentration, and the driving force is concentration gradient. Now concentration gradient is the difference between two areas, means difference between higher concentration area and lower concentration area. That term is called as concentration gradient. Now diffusion is a time dependent process. In pharmacy, diffusion of a drug through the barrier is important. Now barrier means skin or GIT tract, mucosa of GIT or nasal mucosa, all different mucosa we can say as a barrier through which a drug diffuse to show its action. So in pharmacy, diffusion of drugs through barrier is important. The material undergoes transport is known as diffusant or permeant or penetrant. Whatever material undergoes transport or diffusion is known as diffusant, permeant or penetrant. The transport by different mechanisms such as passive diffusion, facilitated diffusion or active transport. Here we can see that there is a net movement of material from higher concentration to the lower concentration. Now whatever difference between two areas from higher concentration to lower concentration is called as concentration gradient, and there will be a barrier. Through barrier, this movement of solid from higher concentration to lower concentration will happen. Now if this concentration gradient is down, the concentration gradient means higher to lower, it is called as passive diffusion, and against the concentration gradient means lower to higher, it is called as active transport. Okay, what are the application of diffusion? First one is release of drug from the dosage form is diffusion dependent. Now many dosage forms like sustained release or controlled release dosage forms designed on the basis of diffusion. These dosage form designed in such a way that at a particular period or at a particular time the particular amount of drug will be diffused from the dosage form. So release of drug from dosage form is diffusion dependent in sustained or controlled release dosage form. Second one is estimation of molecular weight of polymer. Now diffusion, some formulas are there like Higuchi square root equations, which use diffusion of the molecule to calculate the estimation of molecular weight of polymers. Next, prediction of absorption of drug in GIT from diffusion principle. Diffusion principle used to predict the absorption of drug from GIT. Also, diffusion principle used to predict the diffusion of drug in tissues and excretion through the kidneys. It is also used in the processes such as dialysis, microfiltration, ultrafiltration, hemodialysis, osmosis, etc. Now there are different laws of diffusion called as Fick's laws. Fick's first law of diffusion. Now diffusion occurs in response to the concentration gradient. Now what Fick's first law states that flux means rate of mass transfer across the surface area of barrier is directly proportional to the concentration gradient. Whatever flux means the rate of mass transfer across the unit surface area is directly proportional to the concentration gradient. Now concentration gradient means difference between the two areas, concentration difference between the two areas from higher concentration to lower concentration, that will be directly proportional to the flux. Flux means mass transfer across the unit surface area. Now this is expressed by equation J equal to minus D into dC divided by dx, where J is the flux, D is the diffusion coefficient, dC is the change in concentration of material, dx is the change in the distance. Now negative signs here, negative sign indicates that the decrease in concentration, while flux is always remains positive quantity. Now Fick's second law states that the change in concentration with time in particular region is proportional to the change in the concentration gradient at the point of time. Whatever change in the concentration with the time is in a particular region is proportional to the change in the concentration gradient. You can see here that suppose we want to check out the concentration at this particular point with time, that will be directly proportional to the change in the concentration gradient throughout that time. That what the fixed second law states. A change in the concentration with time is in a particular region is proportional to the change in concentration gradient at that point of time, and it is expressed as dc divided by dt equal to minus dj divided by dx. After simplification, means after addition of j value from the first formula, we will get d into d square c divided by dx square. Now fixed first law gives the flux in steady state, means whatever rate of diffusion through unit area, whereas fixed second law refers in general to the change in concentration of diffusion with time at any distance x. Apply for the non-steady state. Fixed first law apply for the steady state, whereas second law apply for the non-steady. Whereas steady state means when the concentration profile does not change with the time. Here concentration profile changes with the time, so it is applied for the non-steady state. Whereas in fixed first law we have seen that concentration, it is not dependent on the concentration profile changing with the time. Now, what are the different transport mechanism of drugs across the GIT? First one is passive diffusion, second one is facilitated diffusion, third one is active transport, fourth one is endocytosis. This one is the passive diffusion. Here this is the lipid bilayer. From lipid bilayer, the drug molecule transport from higher concentration to lower concentration. In passive diffusion, it does not require any cellular energy for transport. This one not required any cellular energy. Transport occur from higher concentration to lower concentration. And example for this transport are transport for soluble molecules, which includes oxygen, carbon dioxide, water, lipids, monosaccharides, etc. And this is a comparatively slow process and bidirectional, means a molecule can transport from this side to this side also. So bidirection, this is a bidirectional process. Now second one is facilitated diffusion. This is also known as passive mediated transport. It is a process of spontaneous transport, passive transport of molecules. Here spontaneous passive transport of molecules from higher concentration to lower concentration across the biological membrane via specific transmembrane integral proteins. Now these are the specific transmembrane integral proteins which helps the facilitated diffusion. It does not require energy like passive diffusion, and it helps to transfer some molecules or ions which are not transported through the passive diffusion. Okay. Now third one is active transport, which requires cellular energy. Which requires the cellular energy. Transport occurs from region of lower concentration to the higher concentration. We can see here from lower concentration to higher, whereas in passive and facilitated from higher to lower. It required in the transportation of all the molecules such as proteins, large molecules, complex, sugar, ions, etc. Here transportation of large molecules such as proteins, complex molecules, sugar, ions, etc. It is a dynamic process, highly selective process. It is a rapid process and one directional. means only single direction process, not bidirectional as in passive diffusion. Now this is difference between active transport and passive transport, whatever already I have told while explaining active and passive transport. It is given in chart form. Finally, endocytosis. It is a cellular process in which substance brought in contact with the cell. Whatever substance are there, they are brought in contact with the cells. The material surrounded by the area of cell membrane. Whatever area of cell membrane will be there, that will be surrounded by the material to form the vesicles. In now, this vesicle contains the ingested material. It is a form of active transport. Again, endocytosis includes two types. One is pinocytosis, another one is phagocytosis. Pinocytosis for smaller ions, whereas phagocytosis for the larger ions. Now, this is about the biological principles involved in the diffusion principles involved in the biological system. In next lecture, we have to see the solubility of gas in liquids and solubility of liquids in liquids. Thank you.